Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where I'm super excited to help jumpstart your school year in AP Calculus. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough to teach, tough to learn concepts accessible to all my students. I'm really excited to introduce our two panelists for tonight, Vicki Carter and Tony Record. Vicki has been teaching high school math for a mere 46 years at West Florence High School. She's a former co-chair of the AP Calculus Development Committee and served and will be serving as an assistant to the chief reader in 2020 and 2021. She received the T-Cube Leadership Award in 2015, and Vicki has served on TI-Nspire authoring teams and has presented at many national, state, and local conferences. So Vicki, we're excited to have you with us tonight.
It is so good to be here with everyone.
And Tony has been a mathematics teacher at Avon High School, a western suburb of Indianapolis, for the past 32 years. And for the past 22, Tony has primarily taught AP Calculus and has worked to build his high school's AP Calculus program to nearly 300 students. In addition to being a T-Cube regional instructor, Tony is an active consultant with the College Board, having produced several AP Live and AP Daily lessons and trained teachers in 27 states. He has authored the AP Calculus AB curriculum for the KIP chapter school system across the United States and has written several test prep materials for various print and online publishers such as Propel Enterprises, Albert.io, and Get5.com. He lives in Avon, Indiana with his wife and two teenage children, and in his spare time he loves to play guitar and is active with Central Indiana's Hendricks Civic Theater, having appeared in several productions, which is very cool. Tony, it's great to have you with us tonight.
It's a pleasure to be here, Michael. Thanks to everyone for joining us.
And Vicki's going to discuss our agenda for tonight.
So first of all, welcome. And we're going to look at some activities and some ideas that correlate to what's called the CED, which is Curriculum and Exam document that is produced by College Board for both AB and BC Calculus. And then we're going to look at several activities. We're going to look at a TI-Nspire activity and a TI-84 activity. So we're going to include both technologies with some different things tonight. And then apparently there's a webinar drawing at the end.
Thanks so much, Vicki. Yeah, I want everyone to stick around to the end because we'll be giving away to one lucky winner a TI graphing calculator. So be sure to stick around for that. If you have any questions for Vicki or Tony, feel free to use the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. And as a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. So without further ado, let's get this started. Tony, you have control. Feel free to share your screen.
All right, well, let's do this. Okay. Vicki, we got your circuit training up. You want to talk a little bit about this?
Yes, I will. So I've gotten into the fad of writing some circuits. Verge Cornelius sort of got me started with this, and I've written several. I felt this was one that was necessary because sometimes my students would come to class beginning in calculus and not have real good calculator skills, and this can be used with either the TI-84 or the TI-Nspire or whatever you may be using. But it was intended to sort of talk about some of their Algebra 2 and pre-calculus skills in various function types. So you can see here for the first several that we've got some trig functions, we've got some radicals, we've got composite functions, we've got exponentials, there's some logs somewhere along the way. Part of it is sort of not exactly a scavenger hunt, but they do have to become familiar with where the keys are located on the calculator, and also operate the calculator. So there are times that multiplication is needed, or a multiplication sign or division sign, or if it's division, making sure they have the right numerator and denominator. And then not just that, but they've also got to think about what is going on with the calculator. So at any rate, this was pretty helpful for my students to get started with the calculator. And now that I'm looking at this, I think maybe we pulled up one, Tony, and it's probably my fault. This is actually the one at the end of the year. So I wrote two. This one is at the end of the year for the calculator, and I have one that is for the beginning of the year that's more Algebra 2, but that's okay. But they're both there and both available, so we can view them and see how they can help the students strengthen their calculator skills. One of the things I have noticed this year is that my students, and I'm guilty of this, my students did not use the calculator as much last year in their Algebra 2 and pre-calculus classes because of many issues that we had with some online learning, surface contamination that we were all so concerned about at the beginning of last fall. And so I don't think they use the calculators quite as much as they should have. And so these two, there are two circuits. There's one for pre-calculus and then after calculus at the end of the calculus course, but they will really help the students with the calculator skills.
Sounds great. And I will attest that these are two fantastic circuits, and they're definitely a pair of my favorites that my students do get quite a bit out of them. And they're so calculator agnostic. Anytime that we can find material that we can share with users of the TI-Nspire, users of the TI-D4, it's really a win-win. So.
And if you don't know what a
Mhm.
circuit, well, Tony, and if you don't know what a circuit is, they've become kind of popular here lately. Essentially, it's a individual scavenger hunt, and the students like them so much because they should get one of the answers that's on the page, and so they can kind of flip the page and look for the answers. But they also are written in many cases where if they incorrectly compute the question or compute the answer to the question, they may find the wrong answer and then they get real boggled down in the circuit and have to find their mistake. So in that respect, it works real well.
Yep, and I know we've been getting a lot of questions about how do we get a hold of these? Well, that's what we're going to talk about next because we thought you might be interested in that. We're basically going to just share a lot of resources with you first, and then, hey, it is a TI webinar, right? So we probably ought to talk about some graphing calculators. So Vicki and I have plans to do that towards the midway point. So awesome. So I guess Vicki, I guess I could talk about some resources. Does that sound like a plan here?
It does.
So, what happens so often, whether you're a beginning teacher or you're a veteran teacher, you're just overwhelmed, right? You have all of these different textbooks that you might be choosing for your adoption. They're all great. You just have to kind of go with your gut and pick what you think would be most helpful for your class. You've got these other peripherals like these online resources like Khan Academy, Calcmedic, Delta Math. Hey, let's not forget AP Classroom, right? It's a very vital part of teaching the course. And yeah, these guys right here are kind of important as well. That's kind of why we're here tonight. But all of these fall under this umbrella of the AP Calculus course and exam description. Some of you who've attended a recent Advanced Placement Summer Institute perhaps have seen some training with this. If you haven't, there's always time to sign up for one during the summer. So what I did with the help of some colleagues, we decided to put together a resource portal so that one could go and find all of these different resources that some of which I've written, some of which rock stars like my co-panelist Vicki Carter have authored. And I know that the URL here that I've condensed, it says Tony's AP Calculus. I don't want anyone to mistake this for material that I've created all 100%. Some of it has been authored by me, but I really honestly believe some of the best stuff are authored by other fabulous teachers. Some of them I'm going to mention throughout. But the elements of the Dropbox would include the guided practice, which is basically some class notes that students could follow along. You're going to see an example of that here in a moment. Some engaging skill builder assignments, much like the particular circuit that Vicki shared at the top of our session. I have several short formative assessments, very small quizzes, if you will, written very AP style. We've got several classroom activities, from card sorts that you can always access to quiz trade activities to jigsaw puzzles. They're all in the Dropbox. And then you've got an AP style unit assessment for each unit. So I suppose if you're watching on demand, you could take a look at that URL there and copy that down, pause the video. And if you're live in the chat, I don't have access to the chat anymore, Michael, but I don't know if you can take that link that I had shared earlier, and you could possibly reshare that, and folks could copy and paste that into their browser. Got to promise me, though, you won't start looking at it right now, right? Wait till the end of this wonderful session that we've got planned for you tonight.
And I would like to say that so many of the activities are both like calculator based and non-calculator. Some of them will have part calculator. Some of the assessments will be part calculator, part no calculator. So there's resources for both technology and the no calculator part, which correlates to the AP exam when they can't use the calculator.
Exactly. The Dropbox is set up like this, just by unit, just as you would imagine. And within each of those unit folders, you'll see subfolders that look like this, that break down each of those particular items that I just spoke about. And I'll even throw a timeline in there that might give new teachers an idea of how you can pace your course. Of course, everybody kind of operates on a different schedule, so a lot of times that's kind of difficult to share. So just really briefly, here's what a guided notes would look like, guided practice. This is the very first lesson, topic 1.1. You'll notice that each one of the lessons is accompanied by this banner that basically is color-coded. You have the big idea, change, with the math practice number 2. That's connecting representations for those of you that are very adept with your course and exam description. It even is color-coded with the color blue, which is associated with that. And of course, isn't it nice to have this learning objective? You never know when an assistant principal is going to walk in the room, right? Taking a look at you and say, hey, these kids have their learning objective right in front of them. If you decide to use these, feel free, change this name to your name, change the high school name to your school, say that you wrote it. I'm totally okay with that. Doesn't bother me at all. But you're just going to see a variety of ways that we engage students by getting into the content here. Here, topic 1.1, can change occur at a point. I want to quickly take note of the Nspire tutorials. Now, I do use the TI-Nspire at my school. I know a lot of you use the TI-84. The things that I have in my notes can be easily modified if you're a TI-84 user, of course. And I do have plans to adapt these documents so that there are quick TI-84 tutorials. There's ways that you can download these font packages directly from the TI website. Very simple to do, and thus you can actually, type a document that actually shows the student what the key actually looks like on their calculator. And I always like to put a little mathematics and history notes in each of my documents to kind of give students a great depiction of where the mathematics came from. But that's basically what my lesson for topic 1.1 would look like. I jump ahead right now, 3.1, probably getting a little bit closer to your calendar, the chain rule, and it's, again, the same thing. You've got your mathematical practice number 1. That's implementing mathematical processes, by the way, and that is a magenta colored in the course and exam description. If I jump ahead here just very quickly to some of the skill builders, notice chain rule is a pretty long lesson, right? Lots of stuff going on with chain rule. We want our students to understand the chain rule, certainly. But if I take a look at our first skill builder, I just want to briefly talk about, we have different styles of skill builders. Vicki shared the wonderful circuit type of skill builder. This is called an acrostic. I would have to attribute Stu Schwartz from mastermathmentor.com. That's the first acrostic that I ever saw. And I really liked these because I thought they were very interesting ways that you could write multiple choice questions and just basically build a crossword puzzle, so to speak, that would spell out some famous quote by a famous mathematician. So they're very, very easy to put together. You could even build these from scratch. I did this basically using Microsoft Word. This is a fairly long assignment. It's a little scary that this is one of the first ones or the first one that my students get, but those questions can be answered fairly quickly. Here's another example of a circuit that we talked about earlier. This one is over derivatives of inverse functions. That's topic 3.3. And so you can see, as Vicki described, you start in the upper left-hand corner, you solve the problem, you look for its answer elsewhere in the circuit, and you proceed accordingly, like a scavenger hunt. Notice some of the problems are very calculator dependent, and there will be an icon to denote that. We have another kind of skill builder. This is called the clue game. The clue game, it's basically another way just to jazz up a multiple choice type of activity. I try to give my students a lot of multiple choice. I feel like the multiple choice section of the AP exam really sets the tone for the score that they're going to earn. And so basically, Peppa Pig has been found dead. I really hope we don't have any really hardcore Peppa Pig fans out there, but we have to figure out who was the culprit. And so basically, the students would just answer these various questions about who was the murderer, where did the murder take place, etc. And we're off and running, being able to figure out who was the murderer and what the actual motive was. I like this. It's kind of ironic. What was the murder weapon? A giant slice of bacon. That's kind of interesting. What else do we have here? Let's see. Whoops, going forward. We have two truths and a lie. Kind of like another, in a way, multiple choice type of activity. This one is over topic 4.2. You're going to notice that Vicki and I's theme tonight is basically centered around the first half of your calculus course, getting through units 1 through 4. We have various bugs that are going to be walking along a straight line, and a velocity equation has been graphed for them, a velocity model. And there are 3 different statements, 2 of which would be true and 1 of which would be false. And for the false statement, what we must do is explain why the statement is false and then write the correct statement accordingly. And I must give a little shout out to a wonderful friend of mine, Brian Passwater, had initially developed this 2 truths and a lie, and he's made several wonderful activities. I kind of tweaked it a little bit with some bugs and some bugs names, and it's been a really fan favorite of my students. And then I think I have one more style, and this is another one I'm going to attribute to Brian. It's called the Big Ten activity. And so throughout the Dropbox, you'll see a few of these, many of which do require the use of the graphing calculator. But basically, a Big Ten is simply 10 questions, which each have an answer that's 0 through 9, and none of them can be repeated. So if you do 2 of these problems and you get 3 both times, you've made at least 1 mistake. So your students would only be crossing off these one at a time as they work through the document. And that would be our various types of skill builders. Again, all of those can be found in that Dropbox, and it's organized in a way that we hope that you can manage to find things pretty successfully. So, Vicki, where are we going to go to next? Are we going to talk about some calculator stuff here?
Well, almost. So one of the things that we want to look at, all right, so you're going to go to the next page, or okay.
Go to this one. Yep.
There we go. Okay, so one of the things that I have found very helpful for the students is to create what I call an interactive notebook, if I can get my tongue untied there. I have correlated every topic in the CED to a page that they would put into their notebook. If you notice, this is sort of a duplicate on the left and right. So I have decided that with my interactive notebooks, we would reduce the use of scissors and a lot of cutting, which I know a lot of the interactive notebooks or foldables and things like this, all kinds of cute little creative things. But I really need to get to the calculus and not have a lot of scissors and stuff going on. So I have either developed it as a foldable, that it's truly a foldable. So there's a side you glue down, and then basically you've got 3 sides, and I print front and back. Or I print it landscape and cut it in half, and they get the half of the page, and it's ready to go in their notebook. So this is an example of the one that's for topic 2.3, which is estimating derivatives. And so my feeling is that they should be able to estimate a derivative from tables. And so I have an example of that here. They should be able to estimate a derivative from a graph. And so I have some examples here. I tried to give one in which they actually have a tangent line and we're kind of just counting rise over run, so to speak, to that parabola. But the second one is actually realizing that if they have a piecewise linear function, that they just need to find the slope of that part of the segment that contains the value of x where we're trying to find the derivative. And so again, it's a rise over run, but they need to make that connection that the slope of the linear piece is the actual value of the derivative. And then if it's something that they've got to be able to use their calculator for, which we know approximating a derivative at a point is one of the big calculator uses for the AP exam, then I try to give them various calculators the way that they would actually input this. So in this case, with the derivative at a point, I'm telling them that you must be able to do this for the AP exam. I have the TI-84 directions, the TI-Nspire directions, and the TI-Nspire casts, which are slightly different in each case. And so that they can reference this later if they've forgotten how to do this on their calculator.
Right, sounds great. I think we're going to transition to some calculator activities. I've got one I'm going to pull up. We're going to talk to, those of you that might use the TI-Nspire, but I need to also preface this. I know a lot of folks that use the TI-84, very popular calculator. It's a fantastic machine, by the way. But a lot of times I talk with teachers about, hey, I've got the 84s in my room. Those are what my students use. But sometimes I like some of the features that the TI-Nspire will demonstrate. And so often I see those teachers perhaps purchasing or using the TI-Nspire teacher premium software to demonstrate things to their students. And then the students can kind of see some of those connections that can be made, but yet it's not going to confuse them because when they go to their TI-84 to do their calculations that they're taught to do, they're just going to benefit from really the best of both worlds. And I want to tell everyone, I was that teacher. Several years ago, when the TI-Nspire software first came out, I had a room full of TI-83s, but I loved that software. And so I used it for about 3 or 4 years. Now, eventually, we did transition our calculators into the TI-Nspire, but don't feel like you can't use Nspire software, even if you are a TI-84 school. And you can always download the software and use it for 90 days free from the Texas Instrument website and get an idea if you think if it would really have a place in your classroom. So what I'm showing you here is it's basically an amalgamation. There's a good word. That's going to be our word for the night, amalgamation of several activities that were authored by various folks that were posted on the TI website, on the math-inspired portion of their website. And so what I wanted to do is just really take the best pages out of all of those documents when I was teaching topic 2.7. Really, it's a very quick topic, derivatives of sine x, cosine x, e to the x, ln of x. Of course, we could just show them the 4 formulas and have them practice it, but they really won't gain a full picture of, why are these formulas the way that they are? And oftentimes I have shown my students the limit definition, right? The derivative definition by the limit of sine of x. I don't know about your students. My students aren't a fan of that proof. They don't like the magical step that appears out of the air that you have to add and subtract some value. They don't like these sum angle formula for sine that they have to use. And so a lot of times I like to try to give them some other kind of a visual that will help them with this. And so what I do is if I go maneuver to page 2.1, we see just the basic graph. It is a sine curve, but I don't really care about that. I just want to remind my students that they can simply take this particular point here, if it allows me to move it all of a sudden, and they can move this around. It's funny how it doesn't want to move when I start talking about it. There we go. Hit tab, that helps. And if we can move this point around, and we just basically see that, yep, they can compute the slope. They can see that it makes sense. We can see that as we get to this hilltop here, we're going to have a slope of 0 at that particular x value. Nothing major really going on here, just making sure we reinforce that the slope of the tangent line is one of our main focuses in calculus. But what I really like is what happens on the subsequent pages. Here on page 3.1, we'll have the students investigate the derivative of sine of x. And so we have a dual pane presentation here where the top pane is indeed the graph of the sine of x. And I have sliders here built in. And with each click on the slider, you can see the slope of the tangent line moving throughout the curve, sine of x. But if you take a look down below, that's where the magic is happening. We see that that slope that's being calculated is being parlayed into a y value, an f prime value on what will end up being the curve of the derivative. And if we click on this just enough, I think the students will come to the realization that yes, that blue curve is indeed the cosine. And it's really wonderful that you have options with this. This would be a great way to introduce what the derivative is before your students ever know, or you could do this after the fact. I think I've done it both ways, and it seems to be intriguing to the students both ways. And I want everyone to know that this would also work on the numeric Nspire. It does not require casts. If we move on to the next screen, you probably can guess what we're going to do here. It's going to look very similar. We now have the graph of cosine, and if we kind of slide along, there we go. We have the graph developing, and we see that, well, okay, it's not the sine. It's kind of the sine all reflected around the x-axis, which that would make it negative sine of x, of course. And so that's a great conversation piece to have with students about the reflection of sine.
And for some reason, when students see these visualizations, they connect what they've seen. They like have a little instant replay of what they saw here, and it really helps them to remember these two derivatives, to have seen these two graphs and how this happens.
It's a great point. I agree 100%. Our graph of e to the x. Now, this one's kind of intriguing because we all know as calculus teachers that the derivative of e to the x is e to the x. And I don't know if you've ever tried to prove this using the limit definition. I've done it with my students. It doesn't go very well because it really requires an innate understanding of a very special limit that involves logarithms and a definition of a logarithm. So I find that my students just sometimes want a little bit more. It's like, well, why is this derivative the same as the original function? And so I just basically took a couple of pages off of a document that focused on this, where it just says, hey, on the next page, you're going to see a graph of e to the x, and you're going to see shown along with it the tangent line at x equal a. And you could start, thinking about using these questions in your discussion if you'd like. But I really think there's so much power and intrigue with this particular page. Now, there's some things about this that might surprise you. I never really understood or knew that if you took the tangent line to the graph e to the x, and if you allowed it to intersect the x-axis, right? Kind of thinking about Newton's method, I guess. And then if you dropped that point of tangency straight down to the x-axis, those 2 points would always have a distance of 1 unit every single time. No matter where we decide to put that point of tangency, we always see that constant 1 unit. And sometimes my students are like, yeah, sure, Mr. Record, that's 1 unit. Maybe putting this right back to ground zero here and knowing that each of these increments is 2/10, you can see that, oh, that is really 1 unit. And now we can start going off to the right and we see that, well, what is the slope of a line? Not so much a tangent line right now, but any line. Well, we define that to be rise over run. And you see that the rise is always going to be the y value on the curve, which is exactly why the derivative of e to the x is e to the x from a visual perspective. So my students were really intrigued by this. I had a lot of ahas when they saw this 1 unit. And then finally, maybe my favorite of the 4 is the demonstration of the derivative of f of x equal ln of x. This one starts with your beautiful graph ln of x that we all hope our students know how to sketch by the time they get to calculus. And then we have a page that kind of describes what is about to happen, and that we're basically going to have a tangent line that we can move around and calculate its slope, and then take those slope values and parlay them into some points that we can connect to make the derivative. So that will look something like this. There's our graph of f of x equal ln of x. Notice that my first tangent line is drawn here when the x value is 0.5. All the dirty work is being done. The slope is given to us at about 2. Notice that the y value of this point is negative 0.01, but if I start moving this movable point, I need to take this up to have a y value that's equivalent to that slope, about 2.07. Yeah, I know this is probably meant to be exactly 2, but it's okay if the students are off just a little bit. It really doesn't matter. Now, if we move this a little bit farther and bring in another point by hitting the slider, I now want to investigate what is happening here at the point where x is 1. Well, the slope here is 1. Well, that's interesting. The slope of the derivative, right? The derivative of ln of x has a value of 1 when x is 1. Okay, well, I'm going to move this until I have a y value of 1. That looks pretty good. And then we just keep repeating that process. Bring in our next point, slide this tangent line over to coincide with that x value. It looks like the slope is about 2/3. So if I put this up at about 2/3, pretty close right about there, move to our next point, slide this along again. And I think you guys pretty much have the idea. It's just lather, rinse, repeat. I don't know if I'll need to do this all the way to the end because we've got some other exciting things we want to share with you. But I want to get just a few more points here to kind of reinforce the fact that this derivative is something that we might recognize as teachers. We certainly hope our students recognize the graph of 1 over x. So we could do that for 3 more points, of course. And I might want to get that a little bit higher, get that to be 0.33. There we go. That's pretty close right there. And then by the time the students see these 3 dots, we can start having, or these 6 dots or more, we can start having the discussion about what you think this might sketch. And why not? Let's open up our graph entry line and let's try it. 1 over x, and it looks like a pretty good fit. And so again, like Vicki said, I think what she said is so important, that when students see these representations and manipulate them, or even watch you manipulate them, if they don't have an Nspire, but yet you have the software, they're going to remember that connection between the derivative of ln of x and 1 over x. All right, Vicki, I think you've got something with a TI-84, if I'm not mistaken.
Yes. So I recently did this activity with my students, and I was very, very pleased with how it came out. And so we're going to go through the 84, but I also have the TI-Nspire that correlates to it. So I tried to find a very interesting function. Basically, we're going to be exploring L'Hopital's rule, which I know is toward the very end of Unit 4. So it might be a little while before you get to this topic. But I wanted to incorporate some other skills that they need to have while I was, thinking about what can I do to lead them and kind of guide them into what really happens with L'Hopital's rule. So this very interesting function that I came up with is shown in Y1, and it's the natural log of x squared minus x minus the natural log of 6 over the product of x plus 4 times x minus 3. So Tony's going to show you this graph. And there are, of course, some interesting features in this graph that I feel are relevant for students to talk about. First of all, our discontinuities in the denominator, where x equals -4, and it's to me, and hopefully to students, it's very obvious that we have a vertical asymptote of x equals -4. But we also had x minus 3 as one of the factors of the denominator. So what is happening at x equals 3? Well, hopefully the students might at least guess that there's a hole in the graph. I mean, it's not defined, so it's not a vertical asymptote. So I think after they've gone through Unit 1 and talked about continuity and limits and various things, that they could easily understand that there's a point or removable discontinuity at x equals 3. You might also want to talk about what's going on between 0 and 1. Well, that's basically sort of a gap in the domain, and that's because we had the natural log of x squared minus x, and so you may even want to talk about that a little bit. But what we want to do is basically think about what the limit of this function is as x approaches 3. So one of the skills that they should have with their calculator is to estimate a limit from a graph. Hopefully they could use trace. Also, a table would be practical, but for today, let's just think about using the trace on this graph. So Tony's going to press trace. And what we need to do is think about observing these y values, and we've got to get over closer to 1 before we're going to actually see some y values here. But we want to think about what would be a good estimate for the limit of this function as x approaches 3. So let's get a little closer to 3 here. So we're getting there. And of course, you could make some adjustments in your calculator. So let's see, we get to about 2.8, 2.95, 3.03. So they might go back and forth between these values. And I really want them to just basically commit to a value. Like, it might be right, it might be wrong, it's okay. But I want you to say, what do you think your best estimate of a limit of this function would be as x approaches 3? So my students would jot that number down, and then I want to look at something else. So instead of graphing the function, Tony's going to go back to the y equals screen. Now, to save time, we did type these in ahead of time. He's going to turn off the y1, so we're not looking at the graph of the function. But what we've now done is graphed the numerator and the denominator separately. So we're going to look at those two functions on the graph screen. And I hope the students can look and think, okay, at x equals 3, this is interesting. Both of the values of the numerator and the denominator are 0. So we need to go back again to Unit 1 and think, well, what happened when we tried to find the limit of a function and we got that indeterminate form of 0 over 0? We had the skills, hopefully, in Unit 1 that we could factor and divide out a common factor. We had some special trig ratio or some trig limits that we could use, which obviously wouldn't have any effect on this problem. We had the tool of rationalizing either the numerator or the denominator. And so we look kind of back at that function again. So Tony, if you just go back to the y equals so we can just look at that function, I don't think any of those tools are going to help us. So let's see if we could maybe come up with something else that we could use. So we're just going to go to a calculator screen. And Tony is going to help us calculate a derivative at a point. Recall that that was on the foldable that you saw, that's one of the skills that the students must have for the AP exam, is to approximate a derivative at a point. So we need to go to math, and then we need to go to our end derivative, which is number 8 there. And of course, we're taking a derivative with respect to x. And we want to find the derivative of just the numerator. So that would be the function we have in y2. Now there's several ways that you can access y2. One of them is, Tony, let's try the vars button, the variables button. And this is a y variable. And of course it's a function. And so the numerator, remember, was y2. And so we want to evaluate the derivative of y2 at x equals 3. So basically we find out that the slope of that numerator's graph at x equals 3 is 0.8333 etc., as you can see on the screen. Now let's do the same thing for the derivative of the denominator. Now, both of these derivatives could easily be found by hand, but I think it's kind of neat to make the connection with the technology, and you'll see why in just a few minutes. So we could go copy that one and edit it, or we could repeat our process of math and nderiv. So Tony is going to just come back in here and edit the Y2. I think he's going to show you a different way that you could find in this case, we want the Y3 because we want the derivative of the denominator x equals 3. Okay. And this one is actually pretty easy because it was a quadratic. So this is 7. Okay, so, why do we even have these? Let's think about something. What if we took the ratio of these two derivatives? So we're going to take the derivative of y2 at x equals 3, the 0.8333, etc. And we can just put divided by 7, since that is a whole number. And my students were actually pretty amazed that they got something very close to that limit that they were trying to find at the beginning. And most of my students had kind of guessed that the limit would be 0.11, either 9 or 0.118. They were really close there, and they were surprised. And so then we kind of talked about what's really going on. So we're finding the ratio of the slopes of the tangent lines of those two curves at x equals 3. And it turns out that if we do this, this will give us the value of that limit of that indeterminate form, that original function that we had, and this is known as L'Hopital's rule. And for some reason, the students had a greater appreciation for what L'Hopital's rule does, and I kept emphasizing, I used this to sort of emphasize why we don't do quotient rule when we see a quotient, because believe me, I've had to spend a number of, little chats with students in class that when they see a quotient and they're taking a derivative, they've got to use a quotient rule. But now here we're looking at a quotient, but we're doing a different process. So I keep reminding them it's not a quotient rule. This is just the ratio of the slopes of the numerator to the ratio of the slope of the denominator. So there's also the TI-Nspire document, and it has a little more of, I guess, what I would call the script of what I've gone through here. And so that's the beauty of the Nspire, is that you have that option. But Tony, if you'll just kind of click through the pages, you'll see that we're basically doing the same thing. We're going to estimate the limit. I was able to put a hole in the graph with this, with the technology there, to make it a little more obvious. And then we're going to graph the two. Again, they both have a 0 at 3, the numerator and the denominator. And then I'm going to talk about this thing, that we've got this indeterminate form of 0 over 0. I think it's really important to talk about that and not let the students think that the limit equals 0 over 0, because I just really hate that. That's a big no-no in my classroom. So we constantly try to refer to it as an indeterminate form of 0 over 0. And then I asked them basically to do what Tony helped us do here. Calculate the two derivatives and then find the ratio of these derivatives. And there's a page in the Nspire document to complete that. It's just a blank page so that they can do that. And then there's a summary on the next page. And so
awesome.
you've got both the 84 and the TI-Nspire with that.
Yeah, I love this. I've already been witness to this when Vicki shared this before we were planning tonight, and I'm like, this is so cool. It's just a great way to show both pieces of technology accomplishing the same goal. Yeah, the Nspire has a little bit more flash to it, but make no mistake about it, the 84, the manipulation that she had put forth with that particular activity, I really think hammers home the point that we're trying to make with L'Hopital's rule, and does it really well. So nice. Let's see, we've got a little bit more time. Vicki, gosh, do you think it's okay if we go into Unit 5 just a little bit, I guess, a preview of some activities for Unit 5? I'll let you decide.
Yeah, I think it'd be great because remember, Unit 1 is limits and continuity. 2 and 3 are both all of your derivative rules. 4 and 5 are various applications. So we were kind of thinking, 1 through 4, that may be where people are maybe not quite there, but getting close to. But 5 is also an application of derivatives. So that's basically what we want to talk about today to jumpstart your school year. And so Tony's got this nice optimizing Coca-Cola can.
You know what? I hope we're not breaking any trademarks. Or I didn't even think about that. Maybe they'll give us a little kickback, give TI a little kickback here. But anyhow, this is a pair of activities that I had put together, I guess, a long time ago. I presented these at a TI international conference, but it's been quite a few years since I've done that. So I thought I would just share them just really briefly here with you to round out our hour. But optimization is what we kind of find ourselves converging upon, no pun intended there, at the end of Unit 5. And a lot of times, if you are the type of teacher for your AB class where you try to get Unit 5 in before your winter break, you find that you have to rush and do a lot of things very quickly. And so I found out that using this particular activity with my students allows them to discover a lot of the things that I'm trying to teach them with optimization without using an entire class period to do so. Now, I am going to move through this rather quickly. You will have access to this if you go to the Dropbox. This would be in the Unit 5 folder, makes sense. Under class activities, there'll be an Nspire folder with all of the Nspire files there. But students just basically are supposed to design a circular cylinder that will hold the standard 22 cubic inches of a soft drink, which equates to about 12 fluid ounces. But they want to conserve the amount of aluminum that they're using so that they can keep that outer surface area to a minimum, because aluminum costs money. Coca-Cola has to spend the money to create these cans, and of course they would like to minimize the outer surface area, all the while keeping 22 cubic inches of that delicious, refreshing beverage inside. And so we just basically scaffold through. We notice that there are various ways that a soda can be designed that might still hold 22 cubic inches of drink. We talk about how to break apart the can into its 3 different parts to help them kind of decide what the formula would be for the surface area. And we have some questions that are embedded for those of you that use the navigator. You could very easily click that little quick poll button on your software, and boom, it sends it right to the students' calculators. We just gradually move through this, and I apologize if I'm going a little too fast and you want to read some of these, but it just, as I said, it scaffolds this so that students could probably do this on their own in an independent environment. Finally, we come up with this secondary equation. That's the equation that we're going to use to equate R and H, because right now we have too many variables. And once we do that, we can come up with our overall primary equation that's going to allow the students to take the derivative and find the answer. And basically, that's what happens through the last several screens. And students are oftentimes very surprised that the actual value of R, just so you know, is not optimal. It's actually a little longer than it should be. This is a little bit longer, and I take that back. It's a little shorter. The R that you would compute that gives you the optimal is longer than the actual radius of a can, and we have measured, and you could even measure that for your students if you have an overhead projector or several cans of soda to pass out to your students. And the reason for that, and I wondered, why are they manufacturing cans that are a lot smaller? I thought it was a conspiracy to get soda cans in the hands of like younger kids to get them kind of hooked on that caffeine, but it's not. We actually have a Coca-Cola bottler here in town, and they said that it's because the aluminum used for the top to accommodate the pull tab mechanism and the aluminum for the bottom is a little thicker so that the integrity of the can can be maintained. And so therefore, that thicker aluminum costs more money, and therefore they have the radius just a little bit smaller than normal. Another activity here is also using the idea of optimization. This is the optimization required to score a goal in soccer. And so in this particular problem, we have the famous goalkeeper, Alfredo Di Ball. he never wants to leave his goal. He always has his feet on the line. And so I end up I created this little visual here. Now, I know it's not drawn to scale, so you soccer enthusiasts will be like, wow, that 18-yard box is pretty big. But in any event, what we want to do is see how close does the player have to be to release the ball in order to maximize, let's say, this angle right here, if he wants to go to the right. Alfredo is this little dot right here, and he can only cover this brown thick line. So anything above here is a goal, or anything below there is a goal. And so again, scaffolding. We label the picture for the students. We have them start thinking about what would be a great way to define angle beta. And once they work through that build, then they come to the realization that they don't have a right triangle, which does limit their options with some of the mathematics that they can do, but it doesn't mean that we can't solve this. We just have to be a little bit more clever. And so again, the scaffolding takes place where they have to write an expression that involves the difference of two inverse trigonometric ratios. Now, I will say that this problem is a little bit on the difficult side, maybe for what students would see on the advanced placement exam, but I think if it's a wonderful, rich problem, it's certainly a great problem for what one would see in maybe a Calculus 1 course at the college level. Students would actually compute that derivative here. Now, this particular activity would involve CAS. Now, you can always do this activity without using the TI-Nspire, of course. And eventually, once they calculate that critical value and figure out how to test whether or not it's optimum, it takes us to this wonderful page here, which is like the grand finale, where a student can actually assume the role of the soccer player, moving towards Alfredo and seeing how that angle beta is getting bigger and bigger and bigger as we get closer and closer to the goal. And they can see about where should I release that ball. The angle's getting bigger still, as you can see, 36.8. And then I think it starts to get smaller. So it's somewhere right around in there that we're going to have our optimal release point. And that should have been computed on one of the previous pages. And I remember this screen. It only took me about 2 months to build this. It was quite intense. And I don't even know probably the first thing that I did to get it built because it was such a long time ago. But a couple of great activities that you can start thinking about as you move into Unit 5. So, Vicki, I think we got the first half of the course wiped out already, right?
I think we did, and I hope we've given you some ideas of how you can incorporate technology in your AP classroom as you are basically going through the various topics in, let's just go ahead and say units 1 through 4. And both Tony and I think I can speak for Tony, are believers in these students really need to have their hands on the technology frequently in the classroom so that they are familiar with it and they're comfortable with it. And they just need to see some of this interactivity, whether it's on the Nspire or whether it's just on the 84, because you can do a lot of things on the 84 to help students understand mathematics via the technology. And so we both believe in that. Use it a lot. Use it from day one.
Sounds great. I can't word it any better than that. Vicki is a rock star. I've looked up to her for a long time. She does great things in her classroom. I'm just trying to let her never leave the classroom. I don't want Vicki to retire. Michael, you want to take us home?
I'm ready when you guys are.
We're ready.
Sounds good.
Awesome. Thanks so much for everyone's participation tonight. It's really been fun seeing the comments in the chat window. And again, I'll be doing some thanks in a minute, but thanks so much to Vicki and Tony for everything they put together. There's, again, a lot of time, I think, spent on some of those documents. So as we wrap things up, please feel free to get any questions asked of Tony or Vicki. I know they'll do their best to get those questions answered live. As promised, for one lucky winner tonight, someone will be receiving a TI graphing calculator of their choice. And tonight's lucky winner is Larry Dodd. So Larry, congratulations. We'll be in touch over email in the next couple of days to give you some more information. But again, congratulations, and I hope you enjoy. To receive a copy of your certificate from tonight, go ahead and click the link in the chat window. Also listed is a link for the documents tonight, which do contain documents that Tony put together, as well as Vicki, and my documents as well. So feel free to visit those two links, and if they're not working for you for any reason, just hang tight, because in a couple of days you'll get a follow-up email, and that email will contain links to the certificate, the documents, as well as the recording. After the webinar, if you're in need of a post-webinar follow-up, give us a call at 1-800-TI-CARES or send us an email, ti-cares@ti.com. We'd love to hear from you. When you leave the survey, a brief survey will automatically appear in your browser, and your feedback guides us as we plan future online events. And so if you liked what you saw tonight, feel free to share that. Maybe we'll look at doing a part 2, or if there's other things in calculus that you really wished that Vicki and Tony would have shared tonight, feel free to let us know that too. Maybe that'll be an upcoming webinar in the future. So with that, a big thanks for Tony and Vicki for everything they put together and shared tonight. Thanks so much, guys.
You're very welcome.
Thank you, everybody.
And thanks, everyone, for joining us. We hope to see you back online next week. Have a great night.